we have 125 grams of acetic acid and 275 grams of aluminum hydroxide. Okay, so we've got 125 grams of this, and we've got 275 grams of this. Now, just like, did I already erase it? Just like we did with the boys and girls. If we want to take a boy and a girl, make a couple, and just do from there, we need to know the number of boys and the number of girls. This doesn't tell us that. This tells us the mass of the boys and the mass of the girls. So the first step, just like we did in the other problem with the boys and girls, so we've got to change these into the numbers. So these are masses. We've got to change them into the number of boys and the number of girls, or in this case, the number of acetic acids and the number of aluminum hydroxides. Same thing, just bigger word. Do you guys remember how to go from grams to moles? Let's talk about what we need to do. So I'm going to come over here to this side piece of the board for a moment. What we're going to do is I'm going to look at acetate. All right, this guy, let's use a different color. This guy here. Okay, it has C's, H's, and O's. So what we're going to do is we're going to break this guy up, and we're going to look at how many of each it has. So it has 2 C's, 4 H's, and 2 O's. Okay. So it's kind of like if you, I won't use an example, it'll just confuse things. So let's keep it simple. All right. So now what we're going to do is we're going to take and look on the periodic table and see how much of each of these things weighs. So a mole of C's weighs 12.
12, yeah.
A mole of H's weighs 1. A mole of O's weighs 16. Everybody know where I'm getting these numbers?
Yes.
This should look familiar. Okay, so I've got 24 and 4 and 32. It's hard to read, sorry. Okay, so if I add that up, that's 4 2s, that's 60. So a mole, that's 60 grams. So that says that 1 mole of that weighs 60 grams. Is everybody okay with that? You remember moles from first year, so you're okay there. If you're not, we'll talk on another time. All right, everybody good over in the regular class? Good. Okay. Now, let's do the same thing with this. How many aluminums?
1.
1. Careful now. How many oxygens?
3.
3. And how many hydrogens?
3.
3. Okay, now, so the hydrogen, same drill. We go to our periodic table. Hydrogen's 1, oxygen 16, and aluminum I don't have memorized. So if somebody have a periodic table handy?
It's 26.
26 point like 99 something, right?
Yeah, 26.98.
Yeah, so we'll keep it simple, make it 27.
Okay.
If you were doing real math, if we were trying to really be accurate, we'd carry a couple more decimals, but just for today, we'll just round it up. All right, so 1 times 27, 27. 3 times 16 is 48. 3 times 1 is 3. So we've got, this weighs 77 grams per mole. Okay, I'll give you a second. All right, now here's what we're going to do. Just like here. Now, I might not have the same numbers you have from the last time, but it's the same basic concept. I told you this, and you had to get to this. We took the pounds of boys, and we went to the number of boys. All right? Pounds of girls, number of girls. Same thing. So we're going to take the mass of acetic acid, and we're going to go like this. 125 grams of acetic acid times Now, before I do that, real quick. Okay. Did you ever do this? If one boy is, let's do it this way. If one boy over 200 pounds, then X boys is going to be 5,000 pounds. Does that make sense?
Yeah.
If the ratio of each boy is 200 pounds, then X boys, we don't know how many boys it is 5,000 pounds. Right?
Mm.
Now watch this. When I change that a little bit, I could bring the 5,000 over here to get it off the bottom to get X by itself, right? So I could go 5,000 pounds times one boy per 200 pounds equals X. True? This is the same thing as this. This is a proportion, and this one is, we okay on the other screen? Good. All right, and this one is just moving it over and saying, this is what I started with right here, and this is a conversion that will get me to how many boys. Well, we're going to do the exact same thing here, except it all got erased because I put this board on top of it. All right, so it's 125 grams times 1 mole over, we're doing this stuff, so 60 grams. Does that make sense?
Yes.
Take a look at that right there and make sure that makes sense, because that's going to equal our number of moles. It's the same thing as saying 1 mole is 60 grams, so X moles is 125 grams. Exact same thing. Okay, so 125 grams, 1 mole out of 60 grams gives us the moles. That's going to be 2 and small change. All right. With the other one, we've got 275 grams. 1 mole is, we figured out 77 grams. We calculated that earlier over here. All right. And so I need to grab a calculator. 125 divided by 60 is 2.08. So this one is 2.08 moles. And 275 divided by 77 equals 3.57 moles. Okay, now I'm going to leave that up for a second so you can copy it if you need to, but it'll also be videoable. And then what I want to do is go in from there, because the question says, how much aluminum acetate can I make? Okay, now, same thing we did with boys and girls. Okay, we went and we said, okay, I don't want to mess this up this time. All right, we said, if I have 25 boys, how many couples can I make? Well, the nice thing, for every 1 boy, it's 1 couple, so we know it's 25. For every girl, we can make a couple, so it's 30 girls. So the one that comes up the least is the one that the amount we can actually make, because we run out of that thing. That's the limiting thing. It limits how much we can make. So we're going to do the same thing here. Now, it gets a little more interesting. Let me get on screen. Okay, it gets a little more interesting because it's not all 1 to 1 to 1 to 1. So here's where we have to be a little careful. So you might have done a railroad track. You might have done a couple different ways in your first year class. I'm just going to show you the way I do with the boys and girls. If I have 3.57 moles of aluminum, how much aluminum acetate can I make? Well, what's the ratio? This is where the equation comes in. I look up here and there's one of these, one of these. So if I have 3 of these, I can make how many of these?
1.
No. If I have 1 of these, I can make 1 of these. If I have 5 of these, I can make 5 of these.
Oh.
If I have 7 of these, I'll make 7 of those, right? So if I have 3.57 moles of this, I can make
3.57.
3.57 moles. So it's 1 of that aluminum acetate thing to 1 of the aluminum hydroxide thing.
Oh, okay.
Okay. Now the other piece of it is this one. Now this is where it gets a little different because it's not 1-to-1. So it's 2.08 moles of the acetic acid. And what's the ratio of these to these? For every 3 of these I start with, how many of these can I make?
1.
Only 1. So I make 1 aluminum acetate, I'll just abbreviate, for every 3 acetic acids. All right, so how much would I make? Well, it's 2.08 times 1 over 3. So that's going to be like 0.6 something. I don't know, 28. So about 0.6869 of this stuff. So which one can I actually make? How much can I actually make? I can actually only make 0.69 moles. And I can make this much, 3 and change with that, but I can only make 0.69 with that. This one's how much I can actually make. So I'm going to run out of this guy.
Okay.
So that is what's called the limiting reactant or the limiting reagent or the limiting chemical. Limiting is because it limits how much you go, like speed limit. You can only go so fast, like that actually works. So this guy is the limiting reactant.